Now, this is graphing inequalities in standard form. Now, we looked at the question before when this was like 2x plus 3y equals 6. And all we've done is we've changed it from an equal sign into one of those inequalities. Now, there are a few rules that we need to know when we're doing this section. So we'll look at those before we start answering these questions. First of all, we're going to pretend that actually it is the equal to. And that's going to enable us to find a couple of points on the line and then join them up. Now, when we connect our points there, we have a choice of whether we're going to do a broken line or a solid line. And the rule that's going to decide that is we're going to do a broken line if it's less than or if it's greater than. And we're going to do a solid line if it's greater than or equal to or less than or equal to. So the equal to tells us it's going to be a solid line. We then have to shade the graph. So we have to decide are we going to shade above the line or are we going to shade below the line. Now the rule that's going to tell us this is we're going to shade above if it's greater than or equal to. And we're going to shade below if it's less than or equal to. However, there is an exception to that. If our question says negative y anywhere in the question, then the negative tells us we're going to do the opposite. So if we see negative y anywhere, and it says greater than or equal to, then actually we're going to shade below the line, so in other words the opposite. And if we see negative y somewhere, and it's less than or equal to, then we're going to do the opposite, and we're going to shade above the line. So we have to keep an eye out for those as well. So first of all, find the x-intercept or the y-intercept, and actually it doesn't matter which way around we do this. So I'm just going to cover this up. So set x equal to 0 gives me 3y. Remember, we're going to pretend this is equal to 6 to begin with, and then we solve that equation. So y equals 2. Set y equal to 0, so this becomes 0. 2x equals 6. X equals 3. So we plot those 2 points. X is 3, y is 2. Then we're going to join them up with a line. Now for you, you're going to have to make the decision, am I going to do a broken line or a solid line? Now as there's no equals, that means we're going to do a broken line. Now I can't do that quite as quickly on my graph. So I'm going to draw a solid line first, and then I'm going to change it, because I want this to be a broken line. There we go. And then the fourth thing we have to do is, are we going to shade above or below? So first of all, check if there's a positive y. So if it's positive and it says greater than, then we're going to shade above the graph. So here's the line. You can pick any point you like on this line. And then if you go above, it tells you we're going to shade everything above this line like that. You don't need to colour in the whole thing, just so we can see exactly which region is appropriate. Now if we move on, 3x plus 4y is 12, same idea. Set x equal to 0, 4y equals 12, so y would equal 3. Then we're going to cover the y up, so y is 0, so 3x equals 12, x would equal 4. Plot those 2 points, so 4 for my x-intercept, 3 for my y-intercept, and then we're just going to join these up with a line. And I'm just going to extend this graph so it goes the whole length. Broken or solid line, well this one's equal to, so I can leave this as a solid line. And this is a positive number of y's, but it says less than, so that means I'm going to shade below the line. So if you pick a point on the line, go below, it tells you it's going to be everything this side of the line. And we're going to skip to the last couple of examples in a second. So we're moving on a few. We skip straight to number 9. No instructions now, so we need to know what we're going to do. So we're going to set x equal to 0 first, and then just solve negative 3y equals negative 9. So divide both sides by negative 3, and I get y equals, 2 negatives give me a positive when I divide, so I got a y-intercept of 3. Then I set y equal to 0, so I get 2x equals negative 9, divide both sides by 2, and I get negative 4.5 on the x-axis, so between negative 4 and negative 5, and then I'm just going to plot them here. Now I've got to connect them up. I have an equal sign, which tells me I'm going to do a solid line, making sure I make this the full length of the graph. There we go. And then now I just need to decide which side am I going to shade the graph. Now less than normally implies that you can shade below the graph, but notice for this one, this is actually negative y. So the negative tells us we're going to do the opposite. So actually we're going to shade above this line. So pick a point on the line, go above, so it's this part here. So in other words, I can shade the whole of this graph up here. Now there's another way you can check this point as well. You could also check a point to see if you get a true statement as well. So I'm claiming that I think it's this region up here. So if I pick a point that lies in here, so this point here for example, 0, 5, if I plug those numbers into this formula, I should get a true statement. So 2 times 0 is 0, 3 times 5 is 15, and yes, negative 15 is less than negative 9. So that's another way you can actually check this. If I pick a point that's on the wrong side, so 0, 0, I plug 0, 0 into here, 2 times 0 is 0, take away 3 times 0, still 0. So 0 take away 0 is 0. 0 is less than or equal to negative 9. Obviously that's a false statement, and that's actually why this side of the graph isn't shaded. So an additional way you can actually check to make sure if you have the right side of the graph shaded or not. Let's move on to our last two questions. Negative 4x plus 2y6. So set x equal to 0, cover that up. So 2y equals 6 tells me that y is going to equal 3. Set y equal to 0, solve this. Negative 4x equals 6. Doesn't divide nicely, this one, so divide both sides by negative 4. That cancels, and 6 divided by negative 4 is negative 1.5. So we've got a decimal, so somewhere between negative 1 and negative 2, halfway. And we'll just have to do the best that we can. No equal sign, so this should be a dotted line, which I can't do straight away, but I can do in a second. And if I just quickly change that, there we go, there's my dotted line. And then now I've got to figure which side I'm going to shade. So greater than normally means above the line. This one is a positive number of y's, so actually it is indeed above the line. So I'm going to shade this part here. Our last question, not such nice numbers for this one either. So first of all, I can set any of these to 0, so I'm going to set this one to 0. 6x is equals 15. Divide both sides by 6. And x is 15 over 6, which is 2.5, so I can go ahead and fill that one in there. If I set x equal to 0, I get negative 5y equals 15. Divide both sides by negative 5. That cancels, and so I get y equals negative 3, which is down here somewhere. Also for this one, no equal sign, so this should be a dotted line. So I'm going to draw a solid line first, and then what I'll do is I'll change that to make sure that I have a dotted line. Less than suggests we're going to shade below the line, but notice we have a negative number of y's here, so that tells us we're going to do the opposite. So actually we're going to shade above this line, so everything on this part of the graph here. Once again, we could check by choosing a point to make sure we had the right side. Always try and pick points that are nice and easy, so 0, 0 is a good one, always to choose. So I think this is the correct side, so if I plug 0 into here, 0 plus 0 is 0 less than 15? Absolutely. So I know that I picked the right side, whereas if I try down here, 0, negative 5, which is the wrong side, the y value is negative 5, so negative 5 times negative 5 is 25, plus 6 times 0, and I got 25 is less than 15, which is obviously not true. And that's also why this side of the line isn't shaded. So that's just your little check to make sure you've actually done this correctly or not.